Hello students, welcome to EduSim. In this video we are going to discuss about interval scheduling, which is a part of greedy approach. In this greedy approach, as we have already discussed, as per the optimal condition, it will work without thinking it twice. Like if you have given a certain problem, suppose find the shortest job. So only shortest job, you can say find the shortest distance. Only shortest distance will be found out. Based on the condition, it will find the result. Okay, it's an approach of greedy algorithm, which we have already discussed before. In this session, we will be discussing how we will find out the non-overlapping jobs, or you can say the non-overlapping tasks we can find out using greedy approach. Okay, so let us start this session. Before starting it, I should tell where I collect the information. This is a book which I told you during the detailed video session, where this algorithm book is quite well known, written by John Klenberg and Eva Tardos. I kept the content, though I told you like detailed video lectures will be based on the book, so definitely we'll focus on the book contents and other type of videos that I have already created or made for you people, which will be belonging to the problem only, like problem based solutions we have discussed there. But in a detailed lecture video, we will be focusing on the content written in the book with the proper algorithm, with the example there in the book that we are discussing. So before going in detail about interval scheduling, I must say why it is needed or what exactly we are finding with a real life example. You can say there are many classes with different classrooms are being conducted in an institutions. Okay, so in that case, what happens, like if a faculty will have similar classes at the same time, there could be a problem, as well as you can say if within a same time with the same classroom, if there might be four classes will be arranging, so that could be a problem. Within a certain classroom we cannot give 2 3 lectures within the same classroom as offline class. This is not possible. So to avoid that, we are actually scheduling each jobs or each task, okay, in such a way that there could not be any problem. So to avoid the problems, we set an algorithm which is based on, you can say, greedy approach. So we are going to read that one. In real life scenario, we can say we know CPU, which is central processing unit. In CPU, what it does basically, it collects the tasks or jobs based on the number of jobs it really completes immediately. That you can say, let us, there are 50 jobs. If it will complete the 50 jobs within certain span, like within suppose 50 seconds or 2 seconds or 3 seconds, the number of time it needed and the maximum number of jobs it will complete within that particular time, 2 seconds or 3 seconds, definitely we can say the performance is high. Okay, so the performance could be enriched if the task could be selected properly and completed properly. Okay, so for that reason, you can say we can do CPU scheduling. Okay, that could be taught in computer organization as well as in operating system too, as well as you can say the classroom. In a classroom, or you can say scheduling classrooms, scheduling teacher, or teacher timing, or scheduling lectures inside the classroom. So these are a part of interval scheduling. Okay, that's why we need it to be done properly. So as per the book, we should know what are the terms or terminologies or key terms that we are using. So interval scheduling is, let us start a job with J. Okay, and that J, what it exactly being represented as J, which is a starting time of the job at J, and finishes with F of J or Fj. You can say it's a finishing time of a J. Let us think job or task could be anything. Suppose you have double clicked on a web browser, or you have suppose given any task. Okay, that time if your CPU is not responding, it will be a hang. So to get it in a theoretical manner, we say it's a job is getting created and the name of the job is a small j. Clear? So the starting time is represented as s of j, and finishing time is represented as f of j. So in that case, we will be deciding which job we will be selecting to run it first. Okay, because once we are selecting one job out of other jobs, that job should not be overlapped. Why we are needing? Because CPU has to keep for this time of this amount of time. Like these are, suppose you can say the times are in seconds. Okay, suppose it is running from 1 to 4 seconds. Within that 4 seconds, within that particular interval, no jobs could be allowed, because you have to focus. Suppose you can ask me, sir, we can go for partial concentration on each jobs, and we will definitely complete all the jobs, not an issue. But can you do, if I'll give you an assignment to complete the assignment of, suppose, algorithm design, and sometimes I can tell you, no, you focus on the algorithm design and you switch to other topics too simultaneously. You do half of the task, not an issue. But can you do that? It's not possible in a real life as well as theoretical life also. Because by doing one job, you are concentrating to complete one job, and you should subdivide it into, suppose, number of times. Okay, and you're focusing like one time. Suppose you have to complete within a one day. So there are five assignments, five different subjects assignments have been given to you, and the teacher told you, that all the teachers for all five subjects, they told you, no, you have to complete within certain time. Means one day will be given to you and you have to complete. You cannot complete if you can subdivide the assignments in such a way that, suppose, for algorithm design, you have to concentrate 1 second, or might be you can say 1 minute you are writing. Again the second minute, like in second minute, you are switching to other subjects, like the same portion or a half of the portion you complete, like a circular manner you are completing five different topics. It could not be possible. Okay, it's better you can focus, like suppose 24 hours, 24 hours, okay, is given to you. Within that, five assignments have been given, five assignment have been submitted by you. So to maintain the time, first you have to decide 4 hours you are going for the sleeping, or the rest of the hours maximum you can uh, invest 6 hours in total sleeping and taking bath, or eating the food, whatever. And rest the amount of time you have to divide by 5, and this much of time you have to concentrate on each job. This is what exactly we are doing in a real life scenario. That is why interval scheduling is more important. Though in exam, before the exam we are not reading. Okay, so the best case scenario is, though we were not reading before the exams, so during exam, whenever the notification is came to us, like we found, might be after 7 days we are having our exam, might be end term, mid term, whatever the exam could be. Before 7 days, if we got it, so we are planning for it. Like we know we have 7 days. Whenever we are actually, these are the interval actually we are doing in our day-to-day life. Okay, so we first have to set it, prioritize it, like when we'll start the job, then which job could be successfully completed. The number of successful completion of that job will enhance our confidence. This is actually in real life we are doing it, but this is how we will be implementing. You just look at here, the two jobs compatible if they do not overlap. Means compatible, it's a term we are using in interval scheduling. Means there should not be overlap. Suppose I'm keeping A and B is overlapped. Why? Because it is not yet finished. It's just time started from 0 and it will be completed within 6. So this is inside the job. Okay, so definitely you can say, if f of j, any job, this is f of j, you can say, if f of j is always, you can say, less or equal to any of the jobs which we will be taking, if the starting time is definitely equal or greater than that, will be considered as j and k are compatible. Means they are not overlapped. You can check it now, don't worry about it. Here this is f of a and this is f of b. That we know, f of b is 4 and f of a is 6. F of a is 6, f of b is 4. That we know 6 is greater than 4. though it's greater than, so we will not accept it. Or else you can say, no sir, we will focus on s of b. S of b you can focus, not an issue, it's one na. Better we will focus on the start time of the second program, the second task, and the finishing time of the first task. Then only we can easily find out which are the jobs which are compatible or not. Okay, you can check here. S of f of a is 6, s of b is 1, so we know 6 is greater than 1. Though it is greater than 1, we cannot say they are compatible, they are not yet compatible. So we can say it is compatible if you can check. If you can check here, this could be a proper example. This is s of g. Okay, s of g. Why? Because the g I have taken as a naming of this one. So s of g, the s of g is 6, f of a is 6, s of g is 6. So you can say 6 is equivalent to 6. So a and g are compatible. Compatible means they are uh, uh, not overlapping to each other. Okay, they do not overlap. So our target here, the goal is set, find the maximum subset of mutually compatible jobs. Means we need to find out the mutually compatible jobs, the maximum number of mutually compatible job. Okay, so here you can say a is, if I am picking a, the compatible will be g, and if a and g will be selected, no more jobs could be selected based on the starting time or any you can say. Suppose I am keeping c. Okay, in this case, if I'm keeping c, so this is f of c, f of c, and I have to consider only f of f, which is, here you can say f of f. Here f of c is 5. Why? Because you can see this straight line. F of c is 5 because of it finishes exactly at 5 seconds. Let us take this as seconds. Okay. Next, f of uh, f of f that we recently discussed. No? This is f of f, suppose. And for f of f, the starting, sorry, this is starting time of f, as a mistake. So starting time of a job is this one. You can check. This is starting time. I'm clearly mentioning starting time is s of a, because this is a job of a, and f of a means this is the finishing time. So we will say compatible if this condition follows, means the finishing time of the previous will be less than equal to the starting time of a new or upcoming job. Then only we can say both the jobs could be compatible or non-overlapping jobs. Okay, here f of c we have selected because c or f are compatible or not. To check that one, what we have to check, we have to go for checking the condition first, whether f of c is less than equal to s of f, means the starting time of the next or upcoming job or not. Okay, for that condition I can find out that this is the starting time, which is 5, and this is the ending time, which is 5. Okay, to get that one, we can say it's 5 now. So whether f of s, whether f of c, sorry, f of c is equivalent to or greater than equivalent to, here less than equivalent to s of f or not. So here we found 5 equal to 5, so we can say c and f are compatible. Okay, because of this condition, compatibility check, this is starting time. Okay, starting time of, and this is finishing time of k, this is, sorry, finishing time of j, and this is starting time of k. This is a condition through which we can say whether it is compatible or not. Okay, so I think it is understood by you. Next we'll switch to the approach to find the maximum number of compatible sets or normal compatible sets. Okay, earliest start time, through this also we can find, means the number of jobs that we are having, whichever is earliest we will find that one, whichever is lowest starting time we'll consider that the last. Okay, the earliest time we will be considering as in ascending order, means in increasing order. First of all, we'll sort it. As for the sorting, we will finding out which one to be selected first. Okay. Next also a second approach. This is first approach, this is second approach. So consider the jobs in ascending order of the finishing time. Okay, so this is starting time, and this is finishing time. Through that also we can find out. Okay, we can easily find out the compatible jobs. And third one is shortest interval, means the time it is taking, like the starting time and finishing time that we know. Okay, so finishing time minus starting time will say you, if you keeping in a ascending order, you can say it is the shortest interval. The shortest the job it is take, the less time it is taking, so that will be selected first. In the basis of that also we can go for finding the compatible set of jobs. And fourth one is fewest conflicts, means you can say the conflicts, means you can say it's a part of compatibility also. Like you can say it's a job. Okay, I'm just saying this one, this is B. Okay, and this is C. Clear? This is C. So in that case what happens, we say the conflicts means within under this, if I'll select A, for A conflicts for A, if I select A, then which I have to ignore is C only. Each one because of C. Okay, means conflicts we are finding, means if I select that one, which are the overlapping that we have to consider. For this B, we have for conflict for A, for B is 1 because of C. Next for C, if I'll say the conflicts for C is 2. Why? Because if I select C, I have to remove A as well as B. Why? Because the starting time we know, the finishing time we know. It's overlapping. If I select C, na, the twos are like A and B are overlapping because of A and B. So this is the conflict. So the fewest conflicts will be selected first. In that case also we can find the compatibility or the set of compatible jobs or the set of non-overlapping jobs. Okay. So the next is the counter example that we recently studied in algorithm design correctness. The counter example is the number of examples you can go for the finding in a indirect way. Okay. So if you can say uh, like if other values you can found suppose and correctness, we have already seen that one. So to check whether it is correct or not, plus B equal to A plus B or not. To check that one, though we know it's a ceiling function, we have gone for A as 1 by 2 and B as 1 by 2. In that case we can say here 1 by 2 the ceiling is 1, and here the ceiling is 1 also. So 1 is 1 is 2, ceiling 1, that we know ceiling is the upper value. So here 1 by 2 plus 1 by 2, the ceiling we have said is 1, 1 ceiling is 1. So through the counter example we have found the results of it. Okay, this is what we have done in counter example. So in this case what we have to do is through counter example also we will check whether it will give us the correct result or not. Okay, as for the earliest start time, we know it will be starting from if I compare with the jobs. Okay, if I'll keep this one, though it is starting one, so the earliest one, if I'll keep this job, so I have to ignore this job, I have to ignore this job, ignore this job, and ignore this job if I'll select this job. Why? Because the earliest starting time not an issue. The earliest starting time I'll pick. Okay, if I'll go for the picking the earliest starting time, so other jobs are overlapping jobs for it. If it is overlapping jobs, I need to remove that one. If I'll not focus on this one, I'll just focus on something else. Okay, so that it is visual to us that there are four jobs that could be selected, which will give us the maximum number of non-overlapping jobs in a single row. It is there, but due to the earliest time or earliest start time, we got as one example. Okay, so shortest interval time. Okay, interval that we have studied, f of j, f of j minus s of j, the less we will be find out, that we are actually taking as a consideration of it. So here there are three jobs. Out of these three jobs, we know it's finishing time and starting time is less for this job, which is third job. If I'll select this one, so I have to discard this, though we know it is visible to us that two jobs could be selected, but due to this shortest interval, we are actually picking this one. This is what actually we found. Okay, and the next one you can say fewest conflicts, that we recently studied over the conflicts. If I'll select this one, so these are not to be taken, means for this the conflict would be 3 because of this. Like this there are here if I'll keep this one, so the conflicts could be possible, like 4 conflicts could be possible. So the shortest we are trying to find out here, the conflicts would be, for this the conflict could be 2. Why? Because this and this. So that is why we cannot pick other jobs, though we know there could be 4 jobs could be selected, but due to this we cannot find out the proper you can say optimal set or proper maximum set of compatible jobs. Because of these are the counter examples we found fewest conflicts. Okay, next, we have written an algorithm through which we will get to know the maximum number of jobs we can find out using these steps. Okay, you can say first what we have to do. Let us take an example of any of the set. Here, you can focus on this one. Okay, not an issue. Just go for it, the sort it by finishing time. Okay, whenever you are sorting, you always keep in mind that you recently studied heap sort, you use heap sort, and whenever you are sorting it, that you know the heap sort is taking a big of n log n base 2, because of there are two children that you are keeping. This is a binary tree, almost complete binary tree, though binary, so two a number of children that we are actually keeping. Okay, for that reason it is base 2. Okay, so yes, first we have to sort it. Why? Because we need to pick one by one out of it. Okay. So once we have done the sorting, next we are actually keeping one array, or you can say a set. Set in mathematics, uh, I can represent in data structure as array. Why? Because it is too easy for us to understand. Okay. Next we are having jobs. J stands for the jobs. Okay. Jobs. Jobs could be n. Let us take, there are many jobs. Like here we have set f of n, with the number of jobs are n. Let us take. Okay. Then if we are saying if j is compatible with a, then what we are doing, a means the set is previously it is empty, like we are using suppose we are finding the sum of two numbers. After just running that program, we have to set sum is 0 first. Initially it is 0, then only we are doing the value. So like that we are writing the array is empty first. Okay, next if condition we have written, where we have just written like job j is compatible with a or not. Okay, if it is compatible, what we are doing, we are just adding that job to the array, or you can say the set. Okay, so union we have written, so it's a mathematical formula formulation while adding the theme in the the set, we are just doing the union. Okay, so then once it is done, within that loop we have written for all the jobs, once it is set properly, then we can say we will return that a, this is a compatible set of jobs we are getting. For this we are getting as big of n, by because it is running for n times, or you can say it's n plus 1. Better you can say it's n plus 1 time. Okay, n plus 1 time it is running. So the whole total, the complexity could be big of the time complexity. I can write time complexity, though it is written n log n, it should be base 2. Complexity could be the first one we have sorted it, so that's why it's n log n base 2 plus big of n and plus 1. Why we have taken plus 1? Also, this is there in a detailed video, though we have to stop it now. Once we have to stop it, the stopping condition could be j is uh, greater than n. If j is greater than n, then it will stop. So for that reason, we are just adding the plus 1 or the constant here. Okay, so though constant is small, we are ignoring that. If out of this n and n log n, the n log n is greater, so that's why we can say, so the maximum one is n log n, so that's why it is said to be n log n. Okay, so the time complexity is n log n base 2. So as for the finishing time, we will discuss whether we are getting the maximum or not. So the finishing time of A, I'm just writing the finishing time. Okay, here the tasks I'll keep, and finishing time I'll keep finishing time. Okay, a small f, I'm writing it. Tasks means J. Okay, here f of J, anything you can write. A, the finishing time would be 6. Okay, B, the finishing time would be 4. Okay, C, the finishing time would be 5. D, the finishing time would be 8. Okay, here J, tasks and finishing time f of J. So I'm just writing in such a way that the 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 space could be properly managed. Okay, so you can write in a under this also, but I do not have space, so that's why I'm writing here. F of 9, E of f of E is 7. Clear now? So a of 6 is the a of, f of 6 is f of a is 6. So from this end, I am just finding out E. Then f finishing time would be 9. Okay. G, the finishing time would be 10. Then for H, the finishing time would be 11. So in this case, what we are actually finding out, uh, like the finishing time, what like for each task as well as the finishing time for that task we found out. Then we sort it. As for sorting, we know the lowest is 4, so B will be selected first. So in A, as per the algorithm, first we have to keep the B as a input first, because it was previously empty. As per the algorithm, I'm just running it. Next we are the picking the next one, which is C. If I'll pick C na, so that could arise a problem, so that's why we need to remove that one. Okay, so I'm just coding it across. Next is the next finishing time will be 5. Then we have 6, but if I'll keep this one, so 6 could be overlapping one, so that's why we have to remove that one. So the next is 7. Okay, 5, then 6, then 7. Once we'll find the 7 here, we have collected this one, and here if I have to check this, okay, so it's the finishing time. The finishing time of B is you can say 4, and the starting time of E is 4. The starting time of E is 4. So here the condition it follows like it is less than AC, so B and E are compatible, though it is there. So this condition should be satisfied, otherwise we cannot say it's compatible. Then we should say yes, it is compatible, so we will keep in the example. Next is came in the set, sorry, which is the A is a number of maximum number of compatible jobs that we are actually finding. Then after this E, we have the next finishing time, which is 8. We have to check D if we are picking E, then we have to remove this D because of this reason. Next, finishing time will be 9, whether it is skipping or not. No, because of E are already selected, so A could not be selected. Okay, so for that reason, we will say it's a discard from our end. Next, 9 after 9, the 10 will be the next highest finishing time. So we have to check whether G could be selected or not. Oh, it's overlapping. Okay, though it's overlapping, we can say we have to remove for a while. Okay, why? Because you can check f of E, you can check is 7, and here s of G is 6. Okay, so in that case what you have to do, f of E should be less than equal to this one. So here it is greater than s of G. So for that condition, E and G are not compatible. So for this condition, they are not compatible. That's why we are not keeping this one. Okay, so next is 11. H will be 11, so we have to check whether they are compatible or not. Yes, they are compatible. If they are compatible, you can say to check the compatibility of it, f of e with 7, and s of h is 8. So here it satisfies. F of e is less than equal to s of h, though it's satisfied. E and H are compatible. Okay, so for this case we are keeping H. So this set is compatible set of jobs. Compatible set of jobs. Clear now? So this is the answer that you can write. Uh, Definitely in the exam, it could be expected where the interval will be written for each jobs. Within that interval, might be in a bracket, it will be written the S of J and F of J format. Suppose the name would be written in this one, and if it will be written F of S of J and F of J in this format. Had not been a tabular format, or if in a tabular form, that could be easy to find out. If this format, like A in bracket 1 2, for this one you can say A in bracket, the starting will be 0 and ending of will be 6. So that could be written. So these questions you can definitely expect in an exam. Okay, so I hope it is understood. Next is interval partitioning. Here in interval partitioning, what we are going to discuss. So the basic thing is, uh, as we discussed in the earlier point, the maximum number of classrooms we need to find for the maximum number of lectures might be, there should not be in a single classroom, there should not be multiple lectures could be done, but yes, at a similar time there are different classes, so definitely different classes could run in a different classrooms with the same interval. Like there should not be any overlapping condition we will be facing. Only interval how we will be partitioned, the interval how will be partitioned, that we are going to discuss. For this example, you can say schedule 4 classrooms. We are having these classrooms here, classrooms like 4 3 2 1. These are the naming conventions of the classrooms that we are having. So here the lectures, these are considered as the lectures. Okay, these are the lectures which are said to be, as per this 4 classrooms, we scheduled 10 lectures. You can just C, B, A, and E, D. These are non-overlapping in case of classrooms. For this classroom, you can say it will be started around 11 a.m. and ending after 2 a.m. And next job we started at 3 a.m. 3 p.m. and next is 4:30 p.m. So this is as per the lecture, we can say as per the goal what we have to find. You can check find minimum number of classrooms to schedule all lectures so that no two occur at the same time in the same room. So same time same room, they should not be there, but other should be there, like different classrooms you can pick for the different lectures, not an issue. But here the overlapping could arise if I'm fixing E here. So if J will be starting here, suppose you can say within that J is written, so E is not yet completed and J is there, so we have to remove that one. Okay, so for this is an example that is given to us through which we can find out the 10 lectures could be easily possible within this four classrooms or not. Okay, so next, as for a certain example, we will check whether the depth is equivalent to the number of classrooms or not. So what is depth also we'll discuss, but this is another example we have taken where three classrooms are given to us. This is classroom. These are classrooms like 1, 2, 3. These are classrooms and these are lectures basically. Okay, these are the class lectures. So we have to find out the same thing, same time, same room. This should not be occur. Okay, that should not occur to like same time or the same number. So what we have to do, we have to just check for the depth. Depth means that in a tree that we are going towards the depth of it to find out the depth of the tree. So here in the same case, we are just checking at 9:30 how many classes we can take or how many classes are being organized. So to get it, there are three jobs we found, and for these three classes, the three different rooms are being there. So here, as per this, it is written the depth of a set the of a set of open interval is maximum number of that contains any given time. If I can go for it, so number of classrooms needed is equivalent to or greater than the depth. Means you can say number of classrooms are three, 1, 2, 3, and here are the classes that are going on. So for this case, there are three classrooms. Okay, that could be if we can say it's a higher. Okay, so the depth could be 3 here as well as we found. For example, the depth of schedule below is 3 ABC at 9:30 here you can check. So schedule below is optimal. We can say the depth we are finding the optimal. Whether it is correct or not, so does it always exist a schedule equal to the depth interval or not? But to check that one, we we found an algorithm. That is what we discussed here. Sort the interval by starting time. First, we sort it in a starting time. Okay, so sort it that it will take big of n log n. Let us take we are using heap sort. For this heap sort, we will be definitely getting other sorting till that we read is definitely give us n square like insertion sort, bubble sort, selection sort. Up to that we read, but recently we discussed how heap sort is working. So in this case we got n log n as a time complexity. Next, this d we introduced were the number of allocated rooms for each lecture. Okay, that based on the lectures we are going to discuss, we are going to decide which room is vacant, which room that we want to shift. Okay, for that case we are having for loop where it runs from 1 to n, might be n number of uh, classes or lectures are there. So for the basis on that, if j is compatible, if j is compatible with some classroom k, let us take suppose some classroom K, J is compatible, means non-overlapping will schedule the lecture J in classroom K. If not, means if overlapped, then what we have to do, we'll allocate a new classroom. Let us take the classroom could be 1, means previously it is 0, so it will be plus 1. Like we added it and scheduled that lecture J in that classroom. Okay, and d value could be d plus 1, the whichever the value that we have upgraded or might be updated, that will be allowed, that will be updated as d value. So here it is, for loop is running, so that's why we say we go n plus 1 to check the stop condition. Okay, where j is greater than n, means it will stop now, then only we can find the result. For this case, the time complexity could be expected as would be big of n log n base 2 plus big of n plus 1. So out of this, the maximum we'll find out as n log n base 2. This is the maximum one, that's why we picked as our interval partitioning. The time complexity for the interval partitioning is n log n. So it is written like keep classrooms in a priority queue. Though we are using priority queue, it's a part of heap sort, though we are doing it, so that's why we expect the less time complexity. So I hope you understood how interval scheduling is working, how interval partitioning is working using the greedy algorithm. Thank you for watching. Have a good day.